Okay, so when we are managing a business, we frequently need to make decisions about the future. In such cases, we don't know situation in the future for sure, so we are faced with risks. So in such case, it is necessary to measure the risks. But before doing that, let me be clear about two terms. One is risks, the other is uncertainty. Um, we are going to use these two terms interchangeably, but strictly speaking, they are different. Okay, risks and uncertainty. Risks refers to a situation in which possible future events can be defined and the probabilities can be assigned. In contrast, uncertainty refers to a situation in which there is no viable methods of assigning probabilities to future events. So in such cases, you cannot ensure uncertainty. But for our purpose, we will use this interchangeably. Right, so we can assign probabilities to some random events. So such kind of in practice, such kind of probabilities can be obtained by repetition or based on general mathematical principles. It could be, in addition, or frequently we use statistical measurement of these probabilities based on the past event. In running a business, there are a number of sources where the risks can occur. The risk can come from general economic conditions. For example, the economy there's boom and busts. It could be industry-wide fluctuations. Because of recession in the particular countries, certain industries are affected to a greater extent. It could be the risk for a particular business. The risk can come from actions of the competitors. My competitors cut the prices. Okay, that's going to affect my profit. Okay, it could be due to technology. There's a new technology which making production more efficient, and which I happen to have no access to it. Then I will be disadvantaged. Risks can come from consumer demand. So there's a change of taste by the consumers. I'm producing alcohol, but consumers become more aware of health hazard of drinking alcohols. Then that's my profit is likely to be negatively affected. Risks can also come from prices of factors of production, like the cost of materials, intermediate inputs goes up, services, labor, wage rates goes up, etc. Right. Okay. So we know that there's something that we are not sure about it. So there's some event which is random, but we can assign probability. So probability is an expression of the chance that a particular event will occur. So probability of all possible events will sum up to 1. And we can have a probability distribution which describes in percentage terms the chances of all possible occurrences, like this. So the cash flow, tomorrow's cash flow, is a random event which has risks associated with it. So it has 10% chance of $3,000, 20% chance of $4,000, 40% chance of $5,000, 20% chance of $6,000, and 10% chance of $7,000. So all these probably add up to 1. Okay, so there are only 1, 2, 3, 4, 5 possible occurrences. Right. So given these probability distributions, 2 cents we are interested to know. 4 cents as the manager of the firms. I'm gonna think on average, what's the average of cash flow tomorrow? So on average, uh, uh, how much cash inflow should I expect? We call this expected value or mean of this cash flow, where cash flow is a random variable. Is the average of all possible outcomes weighted by their respective probabilities. So Ri is a possible outcome. So R1, R2, R3, so on and so forth. And let's weight each possible outcome by its probability P1, P2, P3, so on and so forth. Then sum them up. So that's called average expected value or mean. So this expected value measures how the concentration of the distribution of cash inflow. In addition, we want to measure how spread this cash inflow is. So to do so this is Ri is a particular realization I. Take away R bar is mean. Okay, so this is deviation from its mean. Deviation can be positive, can be negative. So we squared so to get rid of the negative sign. Then weighted this by the probabilities, and then sum them up. Then we call this the term inside the square roots. As actually we have name for it called variance. And with square root back we call standard deviation. So this standard deviation measures how spread the probability distribution of the cash inflow is. And we use this sigma to measure risks. Standard deviation to measure risks. Okay, let's look at these cash inflow probability distributions in Excel. So we know there are 5 possible outcomes of the cash inflow of tomorrow. Let's say we know it's a probability which can be computed from the past events, from the historical data. So let's weight each possible outcome by its probability, so which is equal to A2 times B2. $300. Okay, and be aware that there's unit associated with these possible outcomes. That's dollar. Then sum them up. So that's mean or expected value. So on average, we should expect tomorrow's cash inflow to be $5,000. Okay, so this mean measures the central tendency of the these probability distributions. Okay, in order to measure risks, let's compute the deviation of each possible outcome from its mean. So which is equal to A2 minus C7. And I'm using dollar sign to fix the difference. Okay, so the first possible outcome is $2,000 below the means, so on and so forth. And you want to notice that some deviation is positive, some deviation is negative. So let's square them in order to get rid of negative sign. D2 raised to the power 2. one thing you want to be clear here, in Excel here is still denoted as $4 million, okay, but it's incorrect here. We square $2,000 times negative $2,000 times negative $2,000. That's $4 million square. Okay, you want to be aware that the units is dollar square. So let's do it for all possible outcome. Then weight this by its probability. So E2 times B2. Okay. And be aware that this $400,000 square. Sum them up. We got this variance. And you want to be aware that now the unit of this is dollar square. Okay. So it's $1.2 million square. So dollar square is not intuitive to understand. So dollar is easier. So let's square root back. We call it standard deviation. Standard deviation, which is F7 raised to the power 1/2. So that's $1,095.45. So this cash flow has a mean of $5,000, has a risk of standard deviation of $1,095.45. Okay, this is how we measure risks.